This week on BSD Now, we have a first PlayStation 4 kernel exploit for you. The long-awaited OpenZFS devsummit report by Allan is here. We have DragonflyBSD 5.0 out with Hammer 2. And we also show you vmadm to manage your jails and also give you a little bit about parallel processing with Unix tools in this week's episode of BSD Now. BSD Now, episode 220, Opening ZFS 2017. Hi, I'm your host, Benedict Reuschling.
And I'm Allan Jude.
And we have a great episode prepared for you on this 15th of November 2017. Allan is back from his conference travels late in this year, so this is everything for this year at least, but he brought a lot of stories with him we want to cover in this episode. But for our headlines this week is the first PS4 kernel exploit. Yeah, so this is a PlayStation 4 kernel exploit called Adieu. And so this is a blog post on failoverflow.com. And it begins with, plenty of time has passed since we first demonstrated Linux running on the PS4. Now we will step back a bit and explain how we managed to jump from the browser process into the kernel such that the PS4 kexec et al. Are usable. And over time, PS4 firmware revisions have progressively added many mitigations and in general tried to lock down the system. This post will mainly touch on vulnerabilities and issues which are not present in the kernel or in the are not present on the latest releases, but should still be useful for people wanting to investigate the PS4 security. So vulnerability discovery is the title of this section here. As previously explained, we were able to get a dump of the PS4 firmware version 1.01, the kernel via a PCIe man-in-the-middle attack. Like all FreeBSD kernels, this image included export symbols which are required to perform kernel and module initialization processes. However, the PS4 1.04 kernel also included full ELF symbols, obviously an oversight as they have been removed in later firmware versions. So this oversight was beneficial to the reverse process, although of course not a true prerequisite. Indeed, we began exploring the kernel by examining built-in metadata in the form of the syscall handler table, focusing on the PS4 specific entries. And each entry or each process object in the kernel contains its own IDT or ID table object, and as can be inferred from the snippet above in the blog post, the hash table essentially just stores pointers to opaque data blocks along with given kind and name, and entries may be accessed and thus locked with either read or write intent. Note that IDT_type is not a bit field consisting of only unique powers of 2. This means that if we can control the kind of an ID entry, we may be able to cause a type confusion to occur, which is assumed that we may control the name. And the actual exploitation is to an exploiter within PS4 background, or without any of that background, it might seem that the easiest way to exploit this bug would be to take advantage of the write of the end of the mallocked name d object underscore user t object. However, this turns out to be impossible, as far as that owner of the block knows, because of the side effect of the PS4 page size being changed to hex 0x4000 bytes from the normal.
Right, so it's 16 kilobytes instead of 4 kilobytes.
Exactly. And it appears that in order to change the page size globally, the PS4 kernel developers opted to directly change the related macros. One of the many changes resulting from this is that the smallest actual amount of memory which malloc may give back to the caller becomes 0x40 bytes.
Which is 64 bytes.
Yep, in hex, yeah. While this also results in tons of memory being completely wasted, it does serve to nullify certain exploitation techniques, and likely completely by accident.
Yeah, it's interesting. We were actually talking about the implications of a larger page size like that during, I think it was the RISC-V or the mmap talk, or the VM subsystem talk at BSD Taiwan. Of course, because I went to so many conferences in a row, you'll have to wait for next week to hear about BSD Taiwan.
Yeah, we'll give it to you slowly, one bit at a time. Okay, moving on. So adieu, the named object exploit was present and exploitable, albeit using a slightly different method than described here, until it was fixed in firmware version 4.06. This vulnerability was also found and exploited by at least Chitin Tech, so props to them. And taking a quick look at the 4.07 kernel, we can see a straightforward fix, and which 4.06 is assumed to be identical, only that 4.07 on hand while writing this post, so this was just the version available at that time. So we have a bit of code here in the show notes and also on the website, of course. And we can see that, this is the function, basically, the sysnamd object create structure that's being passed to it. And this results in basically the exploit being possible. And it closes with, and so we say goodbye to a nice exploit. I hope you enjoyed this blast from the past and keep hacking.
Yeah, so it's basically covering something that's kind of overcome by events as the PS4 firmware has been updated. But it's interesting to see all the details on how they did that.
Yeah, and it's interesting that people are still using the PlayStation 4 to do interesting things other than playing with it, of course, on it. So, keep hacking and discovering new things that are possible with this little game machine here.
Yep. So for our next story, we have a kind of a recap of the OpenZFS Developer Summit that happened, was it 3 weeks ago now?
It's been a while, but it's the first conference on your many trips you had this last
couple of weeks.
Yeah, take it away.
Right. So the 5th annual OpenZFS Developer Summit was held in San Francisco, October 24th and 25th, and the schedule is here. And you can see it's got all of the talks with the videos and slides. Interesting to note that the Oracle video is suddenly no longer available. Not sure what's going on there. I do think I know where to get a copy of that video, because one of the places that picked up on it early saved a copy specifically because they assumed this might happen. Anyway, all the videos are there with the slides as well, which is very nice. So it started off with Matt Ahrens did a short State of the Union, kind of talking a little bit about where ZFS is today. And then Mark Mabey from Oracle gave a talk about ZFS's past and future, and specifically how it's used at Oracle, and then going into how they plan to use it and then separately his personal opinions about what he thinks ZFS needs to do in order to become much bigger.
Mm-hmm. Oh, speaking of becoming bigger, what was the conference well attended? Were there more people than last year, or?
Yep, they were at the limit, so they have a cap on the number of attendees based on the space at the venue, and they ran into that cap. So the conference was as full as it could have been.
Mm-hmm. That's a good problem to have.
Yes, in particular, they're not that interested in making it much bigger because we really like that venue, and if you get too many people, it gets harder to talk to the right people and so on.
Yeah, focus.
Yes. But remind me, before we finish this segment, to talk about the upcoming ZFS User Conference for users instead of developers, as that will be open to a lot more people.
Okay, I'm sure to make that reminder. Okay, yeah.
So then after Mark's talk was mine. I did a very short 15-ish minute talk about Z standard compression and what it looks like, and some of the interesting bits of it. There was one outstanding issue in my current code for it, and as is the point of the developer summit, by presenting the problem I was having, as soon as I got off the stage, I think it was Robert Musashi came up and talked to me and told me how to fix it. And then later, I think it was Saso Kisilkov also told me how to fix it.
Excellent.
So they both had the same idea, and I just have to get around to actually doing it. And then we will have, it will make Z standard support all 19 levels or even more than that, instead of just having the 3 levels I was going to put in it, which gives users much more control and makes it possible to do the second feature, which I will talk about in day 2 of the conference.
I can't wait. So excited.
The next talk was by Sarah Harsey. She talked about fast clone deletion. So at Delphix, they often clone whole databases, do a bunch of things to them, and then throw them away. Currently, the way snapshots and clones works is they can maintain what's called a dead list. This is the list of blocks that stopped being used by the clone or snapshot. Right? So if you have a snapshot of a file system and then you delete a file, that list of blocks that normally would have been freed but weren't because the snapshot's keeping them, go on the snapshot's dead list. And that allows the snapshot to figure out, if you delete this, here's the things you can get rid of.
Yep. Makes sense.
So there's that. So the problem with the way they were doing this at Delphix is they clone a file system and then write a lot of data. When they go to delete that clone, it takes a long time because they have to go and find every block that the clone that it added and remove it.
Yeah, it's a long list because a lot of files.
Because they wrote a lot of data. So instead of using that dead list, they use what's called a live list. So as you work on the clone, it keeps tracks of which blocks are only used by the clone and allows them to very quickly delete the clone. So in their most pathological example, it took the time to delete a clone from like 45 minutes to 4.5 seconds or something like that.
That's significant.
Yeah, there's more detail in the slides and video. Definitely check it out. And then from Lawrence Livermore National Labs, Olaf Paland talked about multi-mount protection. So if you have a failover system where you say have 2 separate servers both connected to the same shelf full of disks, it's for high availability, right? So if one of the machines reboots or crashes or falls over, the other one imports the pool and keeps serving the files. Well, the problem is if you import the pool on both machines at the same time, they start clobbering each other and you get corruption and it's terrible. ZFS has some basic protection against that where it keeps track of which machine it's imported on. But if the machine crashes, there's no way for ZFS to tell that the other machine isn't actually still using it anymore. Right? It just says this pool was not safely exported, so you shouldn't import it. So everybody uses the import -f flag to force the import, right? So that they can import the pool. The problem is then you have no protection. So with the multi-mount protection, they scribble in the last Uber block every couple of seconds or so. And then if you're going to import the pool, you look at the label and you read that last Uber block and look at the time. Then you wait a couple seconds and you read it again. And if it's the same, it means nobody else is using the pool. But if it's different, somebody else is still using the pool and you should back off.
Okay.
Yeah. So, it's mostly meant to augment things like SCSI reservations and so on. But it is a nice little protection feature. And I think even using it with something like HAST and CARP on FreeBSD, it solves one of those problems where you can get in this kind of split brain situation. So that is definitely interesting. Yeah, and then there was an update on the port of ZFS to OS X with some interesting details about how that went and which part of it are using like ported Solaris bits versus which parts are native OS X and so on. It was all very interesting. And then he dropped the bombshell on us. Ooh. He also ported ZFS to Windows.
Hell just got a little bit colder, yeah.
Yeah. So as with OS X on Windows, it uses the Illumos slab allocator for memory instead of the native Windows thing. But unlike some people that were confused and thought this was based on the Linux subsystem for Windows stuff, nope, none of that. This is natively compiled as a .sys file and loaded, and that's the kernel module. And then you have zpool.exe and zfs.exe, which are statically compiled binaries, and you have real ZFS. Slightly confusing in that each data set you create shows up as a drive letter. So I don't know what happens if you try to have more than 26 data sets.
The Explorer will explode. Just listing these.
Couple things like that. But very, very interesting. And then in the hackathon, the next day, he actually extended it to support send and receive even. Ooh. So it's getting pretty far along. It's still definitely pre-alpha quality, but this seems like it could meet all of our little dream of having, the ZFS USB stick that you can just stick into any operating system and it works. Right? If it works in Windows, OS X, Linux, Solaris, and FreeBSD, you have your new universal file system.
Moving pools around and heaven. Definitely something to look up.
Windows, I would imagine, is more just a USB stick or maybe a USB hard drive versus, I would only trust Solaris, FreeBSD, and Linux for an entire pool. But anyway.
Yeah. No, that's certainly interesting to see what this will be about or when this is going to be production ready.
Mm-hmm. I don't know if Windows and production ready go together. But anyway. Good stuff. Then there was a talk by Seraphim Dimitriopoulos, who talked about faster allocations. So when you need to allocate space, currently you edit the space map in place. Well, not in place, but anyway. The new faster way would be using a log. So you would just append to a log, I allocated this space here, and I allocated that space here, and I freed and allocated and so on. And every once in a while we condense that and write out the new space map. So this allows a lighter weight version of just appending to a log instead of, copy and writing an entire space map. So looks interesting and could increase performance quite a bit. So that's good. And then a developer from Tguile presented about iFlash, their dynamic adaptive L2 arc. This part's not actually open sourced or upstreamed, but it's definitely interesting to hear about their design of that. And the video and slides are there. And then Intel presented about DRAID, or distributed parity RAID. So this is partly designed to solve kind of the resilver problem, right? So in the supercomputer that they were building, they wanted to have 100 disks. But if you do that the normal way in ZFS, you'd have, say, 10 RAID Z2s of 10 disks each, which sounds reasonable, except if one of those disks dies, when you replace it, the resilver speed is basically limited by the IOPS and throughput speed of a single disk. So the redundancy of all 100 disks is reduced to the speed of one disk. Maybe that's not what you're after. Yeah. Because even when it's resilvering, it's only going to be reading from the other disks in the same stripe. So it'd be 9 disks reading and 1 writing. But you have 100 disks. So to reduce the time that the pool is vulnerable, what they do is all of the VDEVs are actually made up of chunks of all 100 disks. And they use that to create 3 or so virtual spares. Right? So then when one disk dies, you start resilvering immediately to one of these virtual spares. And that virtual spare is made up of chunks of all 100 disks. So it skips the bit for the missing one disk. So that means you're now reading from and writing to all 99 remaining disks to resilver the missing data onto the virtual spare. So very quickly, you get back to being 100% safe, right? Because you've replaced the failed disk with this virtual one. Then, when you actually replace the failed disk in hardware, you slowly resilver back to it the normal way.
Yeah, I remember Matt Aarons scribbling this on the whiteboard at BSD Can this year.
There's a more formal one with slides and a video to explain it from Intel this time. Because yes, even when you're doing the resilver, you're actually reading from all 99 disks again, but you are limited by the throughput speed of the one disk as you're replacing it. But it means while you're doing that slower operation, you're no longer in the vulnerable state where you have reduced parity. So very interesting.
Yeah, as disks grow or the pools grow, this will be welcomed.
Yeah. Yes, especially when we kind of skipping ahead a week to the FreeBSD Vendor Summit where Seagate presented about their new hammer or heat-assisted magnetic recording, where there's a laser on the head that heats up the grains as it magnetizes them to make it easier. They're expecting 20 terabytes by 2020 and going into 30 to 60 terabyte drives very quickly.
Yep, will soon be very, very much.
Well, in particular, Seagate's concern and what they're trying to build new technology around is the problem that while the capacities of the drives keep going up, the random IOPS are the same, right? We've been at about 250 or so for a long time. And so your IOPS per terabyte keeps going down. And so they're trying to prevent that and doing things like 2D magnetic recording where there's actually multiple heads on one arm and multi-actuator where you actually have multiple, your heads don't have to seek together. They can go separately and maybe read more different places on the disk at once.
See, that's why I like ZFS. It's also not just a file system and volume manager, but also deals with the whole hardware and how disks work or SSDs, and all this is kind of part of the
bits I was just talking about are in the hard drive, and they're not related to ZFS. But
yeah, but they need to make sure that ZFS supports these newer access mechanisms or drive speeds or things that come up in the hardware in the future.
Yeah, well, those more you're talking there would be about the shingled magnetic recording, which we learned is not going to go away, is actually probably is going to be combined with Hammer as well. So that gives you, the idea is to provide higher capacity drives at a lower cost per gigabyte for people that just need archival storage, and still offering the regular, Hammer style without the shingling for people that need the higher performance and so on.
Excellent, yeah. Yeah, now that you see the announcement from Intel that they will have 3D X-Point NVDIMM by second half of 2018, it's going to be interesting buying computers in the future.
We'll talk a bit more about that next week because there was some stuff about that at BSD Taiwan as well.
Excellent. Okay, I'm moving ahead.
Yeah, OpenZFS, because we're jumping around a little bit. The last talk of the first day of OpenZFS was by Parakash Surya, who talked about ZIL performance, or how he doubled the sync write speed of ZFS. So especially if you have a slog, but even if you don't with the ZIL, the same thing kind of applies, where he, again, used logging type techniques and better parallelized the way the ZIL works. In particular, when the ZIL was originally designed, all you had were spinning disks, and maybe you had a slog which had a dedicated SSD. But because that SSD was SATA, you were still writing to it one operation at a time. But now we have NVMe, where you can write 63 operations at a time, and eventually even more. And it means that it's a bottleneck for the ZIL or the slog. So he worked out a way to make sure that while operations still have to complete in order to pass the operations up, multiple operations can be going on at once and make better use of the available capacity from the devices. So with this, we should see some really interesting performance improvements, especially when using NVMe and things like that.
Oh, that's excellent. So did they say when they are going to have this upstreamed in their release, or?
No.
Just announcement.
He wants the video a little bit more. I think once it's finished, it'll go in Delphix, and then they do a release, I think, twice a year, and then it will be eventually upstreamed into OpenZFS. Kind of another topic we get to for the second conference, the FreeBSD Vendor Summit, was again my trying to push people to start sucking in features from Delphix and other upstreams into FreeBSD before they go into OpenZFS, partly to accelerate their going into OpenZFS by proving them under production and so on, but just making sure FreeBSD is the role model for ZFS, has all the good stuff first.
Yep, sounds desirable.
Yep. So then the second day was a hackathon. It started with a number of short talks, and then we went into working for the afternoon, where people worked on little projects they thought up and so on. And then we had a little vote off at the end and gave away some Lego sets to the best 3 projects. So most of these are still more at the in-progress stage than the stuff that was presented at the Developer Summit. But at the hackathon, first, George Wilson presented O-Shift, changing the allocation size.
O-Shift?
Yes. The presentation was done very, very well. So with this one, it's if you started a pool when you had 512-byte sector drives, but now you have 4K sector drives, because maybe it's the only replacements you can buy, or you've got bigger disks or whatever, it can really hurt your performance when there's that read, modify, write going on for every sector write. So he's devised a way in which you can have time-dependent geometry where new writes will happen always rounded up to 4K instead of 512 bytes, meaning that mixed drives will now all perform well. You run into a couple of minor issues. That part of the reason for the presentation was to seek feedback on how to solve those. And at least one of them was solved by one of the other presentations working around a similar problem. And as soon as it was mentioned in that presentation, George and I looked at each other and I'm like, you could use that, couldn't you? And he's like, I think so.
Yeah. He has the solution to my problem and vice versa.
Yep. Then second, after that, Matt Ahrens gave a proposal for increasing the performance of dedupe by 1000x.
Ooh.
Yes. So this is 2 different ideas he has, but because Delphix doesn't use dedupe, he's not going to write them, but he's provided the ideas and is willing to help if somebody else would like to write it. So if some company has the use case for dedupe and would like to fund this or assign a developer to it, resources are available to help them get started. But the basic ideas here are, the first is the dedupe throttle. So we set a limit on the size of that dedupe table, so it cannot take all the RAM or get larger than RAM and kill performance. Then when it's full, we stop deduping. But to mitigate that a bit, what it does is when you try to do an insert and the table is full, it looks through the table and randomly finds an entry that has only 1 reference. So this block is only written to this once, and so hasn't been deduped yet. Then we delete that from the table.
Yeah,
so normally that'd be a problem, right? You want the table so that when you delete a file, it can look up that block in the table and reduce its ref count by 1. And if it ends up at 0, then it frees that block. And if it's not 0, then somebody else is still using it, and we better not erase that.
Yeah, important that.
Yeah. But if the table entry is 1, meaning there's only the 1 file using it, then we can delete that row from the table and put this new block in. And when we go to free the file we deleted from the table, if we don't find it in the table, we know it was deleted because it only had 1 entry, so we know we can free it.
Okay,
so it still works.
Sense. Yeah. It's an optimization.
So this will basically remove blocks that haven't been deduped so far. They've been around for a while and they've never managed to find a duplicate. We delete those and put newly written blocks in the table in hopes that the newer written block has a better chance of being written a second time closer together and basically being deduped. So that keeps the table smaller and more manageable. And what else?
Compact,
keeps it smaller and more
basically,
manageable, but doesn't require you to just turn off dedupe as soon as you hit that limit. Then the big performance improvement comes from switching to a log, kind of like we did with the space map. So currently, the dedupe table is a hash table in memory, but also a hash table on disk. So every time you write a block, you maybe dedupe it, maybe not, whatever, you end up possibly having to write like 7 IOPS, right? You write out the block, but then you have to write out like 3 copies of the metadata and then 3 copies of the changes to the dedupe table.
That's
so
extra.
instead of doing 1 write, you just did like 7. With this, we'd instead just append to a log saying, I added this block. Or, this hash went up by 1 or this hash went down by 1.
But it's not a file on the pool. It's some internal file that no one can access from the outside.
Right. It's a log in the metadata, basically. And then every so often, we compress that into just a straighter table so that the time to load it on reboot is not long. So every so often, we'll just smush it down and be like, oh, this file has 7 references. And then you would append +1, -1, +1, -1, or whatever after it, instead of having to read the whole log and add up all the pluses and minuses to find out what the number is. But with that, you have a lot fewer IOs and should definitely increase the performance of dedupe. If you want more information, videos and slides are there. And if you are someone interested in working on this, or especially a company working on, or a company interested in funding it, you can get in touch with me or Matt or someone, and we can help you get started on that.
Yeah, definitely. This is if someone is very heavily using dedupe and still worries about that has some drawbacks currently, this might be a good reason to invest some money in making it better.
Yep. So then Dato, and Tom Caputi, who's the guy that did the native encryption in ZFS, has been working on a new prefetcher for sequential scrub. So this is a smarter prefetcher to make sure that when we do scrubs, we fetch the bits we're going to need more smartly. Instead of walking the tree kind of this way, it walks it this way. I don't know. The presentation explains it better than I can off the top of my head. But with this, it makes scrub preload the right bits so that when it's actually doing the work, the blocks are already in memory. And that kind of relates separately to Saso Kisilkov's work on improving resilver. That's his work that tries to reduce the amount of random I/O by, as you're scanning the data, you read the metadata, but you don't actually read the data blocks or write the improved or the recovered data blocks. You build a range tree in memory of the blocks that you actually want to read and write. And as you do that, you have a fixed area of memory, and you start filling it with these ranges, and they'll be kind of scattered all over the place. Once the memory is full, then you find the biggest contiguous block of work in that table, and you go and do it. So you read from the remaining drives and write to the resilver drive. Then you go back to scanning. Continue where you left off and keep scanning, filling up that range tree again. And when it gets full, you take the biggest block of contiguous work and do it, and then go back to scanning. This way, you're always doing big, chunky work instead of completely random. Instead of having the disk jump all over the place, you read the metadata, and then you do a big chunk of work that's all in a straight line and will allow you to maximize the performance of the disks.
Excellent. That's how it's supposed to be.
Yeah.
Well,
So that would be a nice improvement.
And you worked on your Z standard on the second day?
We'll get to that in a minute. And then Seraphim also talked about his storage pool checkpoint. We had covered his blog post when he did it. But this is the idea where you can basically save the Uber block of the pool from a certain time and block all freeing operations such that you can roll the pool back and undo pretty much anything, including adding extra drives or renaming a data set, or even deleting a whole data set. So even ZFS destroy can be undone with a checkpoint. So more details on how that works are in the slides and video there. And then lastly of the presentations, Matt Ahrens talked about the RAID Z expansion work.
Sponsored by the FreeBSD Foundation and IX Systems.
Yes, this is sponsored in part by Delphix, FreeBSD Foundation, and IX. This work will allow you to take an existing RAID Z 1, 2, or 3 and add a single extra drive to it, widening it. This is something especially like home users and home server people have been after since the beginning. It's like the single most asked for feature in ZFS.
Yeah.
And so the FreeBSD Foundation worked with Matt Ahrens to fund him working on it. So he talks about how it will work with some nice graphics, and promises there will be a presentation at BSDCan showing his progress on it. And then hopefully by the time next year's OpenZFS Dev Summit comes around, we will have workages.
Well, that's a good outlook for next year.
Mm-hmm.
Yeah, excellent.
And then there was the hackathon where people worked on various projects. I had 2 ideas. Couldn't really work on both of them though. So the one I ended up working on was adaptive compression. So taking the idea of Z standard a little further, especially since at the conference they had figured out for me how to handle all 19 levels instead of just having 3. Eventually, once this feature is done, you'll be able to set compress equals Z standard dash auto, and probably there'll be a sysctl to set the minimum and maximum for it, but whatever. With this, the compression will start at the highest level that you specify, and it will try to compress as much as possible any data blocks you write. But it keeps an eye on how much dirty data is pending, how much data is waiting to be compressed and then written out to disk. If that number is getting too high, meaning that your CPU can't keep up with the amount of compression you're doing, then it will start ratcheting the compression level down until it finds this point where it's compressing as much as possible, but still keeping your disks busy, or making sure that there's not, the flushes can keep up and you're not actually queuing up people waiting to be compressed.
Yeah. Is that across multiple CPUs or a single one? Yeah.
This is across all your CPUs. So by default, I think ZFS uses all -1 of your CPUs to do the compression.
Yeah, to have some...
And the threads that do the compression are lower priority, so other work on the CPU will take priority so that the compression won't, steal all your CPU time. So if something is using all your CPU time and, the compression isn't getting enough time, it'll turn the compression level down to make it work faster. Because, Z standard ranges from like 700 megabytes per second per core down to like 3 megabytes per second per core, depending on the compression level you set. So having it auto-select through there to find the compression level that will save the most space without killing performance will be quite interesting.
And in the worst case, it would probably, if the CPUs are too busy doing other work, then it will probably just stop compressing them together.
Basically go down to the lowest compression level where the CPU impact is very minimal.
Okay, that could work.
Where it compresses so fast that your disk couldn't possibly keep up.
Yeah, we have fast CPUs nowadays, I hear. But depending on the workload.
Some of the other projects people worked on were interesting. There was the FreeNAS test integration, setting ZFS properties using channel programs. So setting many properties at once, quite useful. Compressed and dedupe send stream bug fixes, metaslab allocation PR testing, some other proposed dedupe improvements. Then what I did was another idea I had was combining that adaptive compression idea with Smart Compress, which is a feature from Nexenta where per file, it keeps a little history of how compressible the file has been.
So this has
been around
later
since before, and it's mostly used with LZ4 or gzip. But it's like, if the first couple of megabytes of this file didn't compress, I'm just going to stop trying to compress this file, and then every once in a while I'll retry one block to see if it's changed. But it will remember, all right, the file I'm writing here is a video. It's not compressible. I won't even try to do the compression.
Don't bother.
Yeah. Well, combining that with the adaptive compression can provide a hint on, don't start at the maximum level and end up working down on this file because we know it's not compressible, so we'll just skip it.
It's a hint.
Or we know that, this level makes most sense for this file.
And if the file changes, would that trigger the recompression check?
Well, sorry, it's not if the file changes. It's just if you're writing more blocks to the file and suddenly the file becomes compressible. Some files, a chunk of the middle of the file won't be compressible, and you don't want that to end up disabling compression for the whole file. Especially if the file is, say, a database where, rows of text that are compressible and then somebody uploads an image that isn't compressible or whatever in the database. So it just means as you're writing to the file, it just samples randomly every so many blocks and rechecks its assumption that the file is compressible or uncompressible.
Oh, this is definitely a good place to share ideas and get something working.
Yep. There was also optimizing the Fletcher 4 algorithm on Illumos using some of the newer CPU instructions, porting those enhancements from Linux. I think there's a PR in FreeBSD for doing the same thing, actually. Some man page update stuff. Michael Dexter worked on benchmarking to create large directory structures. There was also some works on z-test reproducibility. So trying to make it so that when you run the ZFS tests, that if you run them twice, you can get the same results. And then also a set of tags for controlling the ZFS test suite. And as I mentioned, the getting ZFS send receive working on Windows. Then there were a couple other things. There was the first prize went to Don Brady, Pavel Sakharov, and I can't pronounce the other name, sorry. They worked on ZTour, which is something that was started 3 or 4 years ago. But it's basically a fuse abstraction layer for ZDB, the ZFS debugger. And it makes a virtual file system that allows you to look at the on-disk format as if they were files. So kind of semi-graphically browse the metadata of ZFS. Quite useful for understanding what's happening.
Yeah,
and,
it's like a meta debugger.
Brian Bendelhoff from the ZFS on Linux project worked on FiMap, which is a way to expose the file segments and holes and what do you call it when you truncate a file and it's actually not there? Sparse files. And using the standard Linux API. And then another group ported MDB to Linux. As we mentioned previously, John Baldwin's already started a port of MDB to FreeBSD as well.
Yep. I look forward to that.
So lots of great stuff happening there.
It seems like no stone was unturned in ZFS or in zpool. It's kind of everyone's working on making it even better than it already is.
Exactly. And then, yes, as I promised to mention, there will be these ZFS User Conference, which will be held April 19th and 20th of 2018 in Connecticut somewhere, I think. Norwalk, Connecticut.
Ooh, let me book flights right now. So this is intended for users?
Yes.
Of ZFS for sharing ideas and how they use it?
So there was one last year. I didn't get to go because the dates were much too close to Asia BSDCon, I think. But they fixed that this year.
Excellent.
So they had interesting talks last year. They had a keynote by Matt Ahrens, but they also talked about, large home scale, labs and stuff. How to do backups and stuff. So a lot, very home user type focused stuff. Then there was just a user that did a file system comparison between different file systems. Tony Hunter did a kind of sysadmin oriented, the way they do monitoring and management of ZFS at Lawrence Livermore National Labs. There was a talk about performance analysis and tuning, talk about fragmentation and pathological workloads, and Don Brady talked about his pool allocation classes idea, where you could, have all your metadata on an SSD and similar things like that.
Cool. Do they have a website or?
Yep. It's zfs.datto.com. DATTO.
Oh, okay.
And they're looking for speakers. So.
This is so horrible. My half of the next year. Well, this is a good problem to have actually. Half of my year is already planned with conference travels and other things.
I spotted a typo on their website already. They have the Friday being in a different month than the Thursday. I have to point that out to them.
Oh, March and April. Yeah. Oops. But yeah, this is something I should look more deeply into.
Yes, I noticed they have one speaker already picked up. Our friend Calvin do you remember Calvin from BSD Can?
From the top of my head,
no? Okay.
Did he give a talk there? Or?
I don't think so, no. Calvin Hendricks Parker. I think he helped with the video streaming. Anyway.
Yeah.
He's going to be speaking.
Streaming games.
He uses ZFS at his company. And then there's lots of slots open for other talks. So we'll have to get those in there.
Excellent.
And for the show notes, we also have a recap from Michael Dexter, who went to the OpenZFS Dev Summit. And so there's pictures and more talk about what happened and from other people's perspective. So you can definitely check out that link in the show notes.
Yeah, there's a lot of stuff to digest from a good conference. And I think there will be another one next year. So
yep. So check that out. Mm-hmm. And speaking of IX systems, that brings us to our chance to thank our sponsors. So if you head over to ixsystems.com/BSD Now, you can check out their guide to buying a new server for open source. And, do what I do and get in touch with them and tell them what you need, and they will do it. I now have all 10 of the servers that they built for me are up and online and doing work.
Yeah, and they're very familiar with ZFS, and they built pretty much all of their storage systems with ZFS, be it the FreeNAS Mini or their big server system like the True Rack, or they even have JBOD enclosures for you. So pretty much anything you can think of. So if you contact them, tell them what you are going to do with this server, what you're planning to do with this server, and then they will tell you what kind of components will be the best thing for you in terms of, like, if you need to have a big storage space or if you want to have a certain performance that you are requiring. So they can build and tell you what components you require to have the best system for that specific purpose. So don't just tell them, I need a server with these components. Tell them what these components should do, what the problem is you're trying to solve with this server. And then they can make you an offer that best fits your needs in terms of storage or CPU-wise, or if you just want to have a big backup server, this is pretty much the go-to company that should answer your questions and give you the right components that fit well together. Yeah,
for me it was the delivery window was going to end up being while I was in the middle of traveling to California and back, and then California and back, and then Taiwan and back. So I really needed somebody to take care of it all for me and to make sure all the servers get delivered to the right place, that they're pre-configured so the data center can just plug them in and go. And IX Systems managed to do that for me. They get it all sorted out, and all the servers are online and doing work, and making money, and I'm happy.
Yeah, this is what you would expect from your server vendor. but not all of them do it. So
yeah, I don't think most server vendors could have handled an order. It's like, I want 10 servers, and I want them shipped to 9 different places. And those places span 2 different countries. And I need all this setup done ahead of time so that the machines arrive and they just be plugged in.
Properly labeled and all that.
Yes. And this is why Scale Engine uses IX to build our custom appliances, because they're the only people that can handle this for us.
And if your storage needs are a little bit smaller, like home needs or home backup or small office backup, then check out the FreeNAS Minis or the Mini XL. These are pretty much good solutions to get started with backups, all backed by ZFS, of course, and then you can slowly build over time if you need more storage, add more disks to it, or put in bigger disks. So all of this is still possible, and it's extendable for future use.
Yep. So our next story, the release of Dragonfly 5.0.
Yeah, so we covered this a couple of times when they had the pre-releases, but this one is now out of the door and brings the first bootable release of Hammer 2, which is Dragonfly's next generation file system. So we have all kinds of file system content in this week's episode. So for people who haven't heard about Hammer 2, Hammer 2 is basically Dragonfly's successor of the Hammer 1, which is their file system they developed. And so the preliminary Hammer 2 support has been released, and we covered that in the show a couple of weeks ago. This has been released into the wild as of the 5.0 release, and this support is considered experimental still and should generally not be used in production. And as much as you would like to test it out, don't use it in production yet, and stay a little bit low, but you can experiment in your test lab with that, and the bootloader will support both UFS and Hammer 2 boots, and the installer will use a UFS/boot partition even for a Hammer 2 installation, because the boot partition is typically very small, and Hammer 2, like Hammer 1, does not instantly free space when files are deleted or replaced. And Dragonfly 5.0 has a single image Hammer 2 support with live DDUP for copies, compression, fast recovery, snapshots, and boot support. So Hammer 2 does not yet support multi-volume or clustering, though commands for exist. They just need to do the actual implementation or refine that a little bit more. So they asked to please use the non-clustered single images for now. There are also updates for IPFW, and their IPFW has gone through a number of updates in Dragonfly and offers better performance. And PF and IPFW3 are also still supported, so you have a choice of which firewall you want to use.
Yes, looks interesting. I need to find some time to look at that a little more closely. They also have improved graphics support. The i915 driver has been brought up to Linux kernel 4.7.10. The Intel GPUs are supported up to the Kaby Lake generation. More interesting to me is this new module they added, VGA Switcheroo, which allows the use of Intel GPUs on hybrid graphics systems. So that with the new Apple GMUX driver enables switching to the Intel video chipset on the dual Intel NVIDIA and Intel Radeon MacBook computers.
Excellent. Yeah,
having something like that for my Lenovo would be awesome.
Yeah, maybe it's adaptable to other systems or other GPUs.
Yep. They also changed the EFI setup program. And another interesting one, Dragonfly now supports over 900,000 processes on a single machine instead of the 100,000 of most Unixes.
Ooh.
Yep. The client-side SSH by default does not support password authentication, being where you provide the password at the command line, not being the keyboard interactive where you type in a password. It's a bit different. Since that is now the default behavior on newer versions of OpenSSH, you would have to explicitly pass -o password authentication equals yes, or change the default etc ssh underscore config to get the old behavior. But you really don't want to be passing around your password statically like that anyway.
Yeah, you use public keys, you're better off with that, where it can be used. They also have
the list of changes from Dragonfly 4.8 is extensive.
Yeah, it's just the best or the stuff that we find most interesting for you. The list is long, and they also have an update on Clang. So more and more open source operating systems seem to get the hang of removing GCC and switching to Clang and LLVM. So they started a framework for that to use Clang as the alternative base compiler in Dragonfly to replace the older GCC 4.7. It's not yet complete, but Clang can be, of course, added as a package, and you can pretty much experiment switching between compilers there. There are also a couple of package updates, a lot of them actually. Most notable is Chrome 6.0 or Chrome 60, finally getting into dports, which has accelerated video and graphic support, and 64-bit status updates also. So note that Dragonfly is a 64-bit only operating system as of 4.6 and will not run on 32-bit hardware. So either switch to 64-bit systems or, cannot upgrade your Dragonfly BSD to that later version. And the AMD Ryzen CPU is supported, and Dragonfly 5.0 has a workaround for a hardware bug that's been found, and you can find more information in our listed show notes. There's also a quickly follow-up release, so there's Dragonfly 5.0.1 available with a few patches, so you should get them while you're updating to Dragonfly, and then you have the latest stuff from them. So it's interesting.
That improves the capacity calculation for the Verdile block driver, which is important if you're running it in a VM. Fixed mount hammer 2 and NewFS hammer 2, so they're on the initrd list so that they're created that way. Fix some other stuff. Remove some of the debugging messages that slipped into the kernel. Added fetch to the initial RAM disk. Bunch of other stuff.
Okay, that's good.
Oh, and they synced the time zone information because there was a very short notice change to the time zone for, I think it was the Sudan. Some country in Africa changed their time zone unexpectedly.
Okay. Yeah, so check out Hammer 2, and if you are doing something interesting with it, or just give us a report how it goes, then send us to feedback@bsdnow.tv, and we'll cover it in a future episode. So after this reporting from conferences and other interesting bits, it's time for our news roundup this week. The first item we have is vmadm, or managing FreeBSD jails. So it's a managing framework for FreeBSD jails over at Project 5.0.net.
Yeah, so this is the first release of vmadm, which is basically a clone of the Solaris tool designed to use FreeBSD jails. So it's still, in progress thing, but they built a command line tool that makes it easy to manage your FreeBSD instances. So you can see they boot up a FreeBSD and run vmadm list, and you can see there's nothing there, but they have one image of FreeBSD 11 available as a jails dataset. And there's a little video that will play eventually. Maybe.
One of these days.
Anyway, and it shows it working and stuff. They provide pre-built dataset images for FreeBSD 10.0 through 11.1, but that list will grow, especially now that there's a community-driven list of datasets. While these datasets, you can't use the SmartOS ones on FreeBSD, obviously, but you'll be able to eventually have FreeBSD jail datasets as well. But after you fetch the dataset, we can define jails by just using a JSON file. This file is compatible with the zone descriptions used on Solaris. It does not provide all the same features, but some subset. Resources such as CPU and memory can be defined, network configured, a dataset selected, and necessary settings like the hostname can be set. when the jail is created, the vmadm allows managing its lifetime, starting it, stopping it, accessing the console, destroying it, etc. Updates to jails are supported. As of today, the only taken into account when you restart the jail, but that's just that they haven't got around to being able to live modify jails yet. It's also worth mentioning that vmadm will not pick up jails created in other tools or created manually, only those using the vmadm tool. That's probably on purpose to make sure it doesn't interfere with any other jails you have running, so you can safely try it without having to switch your jail tool. So they're looking for feedback, especially from people using FreeBSD, and they're currently hard at work integrating FreeBSD's hypervisor bhyve into their FIFO tool as well.
Excellent. That's good to hear.
They say right now, only the bare-bone functionalities are supported. Some of the output is not as clear as it could be, and they hope to eventually add support for bhyve to vmadm the same way it supports KVM on SmartOS. Moreover, the groundwork for this already exists in the nested jail technologies, so it shouldn't be too bad. Other than that, they're also exploring ways to allow for PCI pass-through in jails. Not sure how that'll work. And then in general, they hope to improve compatibility with SmartOS as much as possible. Since the time of this post, it's also been announced that the port of bhyve to Illumos has been open sourced. So a number of years ago, there was a port of FreeBSD's bhyve to Illumos for an appliance company, and they've now open sourced that, and it's being integrated into SmartOS.
Oh, great.
So that's interesting to see as well, and might make this work make even more sense when bhyve supported on both SmartOS and FreeBSD. Having a tool that works with both will be really nice.
Yeah, and we'll be able to, move VMs from one to the other system maybe, or having more engineers looking at the bhyve code also during that could make bhyve even more interesting, and getting more features in there is always good to have, or even bug fixes.
Next
Great.
up.
Yeah, so check out that tool. And also we have an item called parallel processing with Unix tools. So over at Pixelbeat, we have a listing of various ways to parallel processing in Unix. So the first one is piping off, of course, which is the more general one we have. So this is an often underappreciated idea in Unix pipe model, is that the components of the pipe run in parallel. This is a key advantage leveraged when combining simple commands to do one thing well.
Yeah, so when you have a pipe, it's not, the first program runs until it finishes, writes it all to the pipe, and then the second program reads it all and starts working. The first one's outputting and the second one's inputting while they're running in parallel. So it allows two things to happen at once.
Yeah.
But that's about the extent of it. You can't really do, four things at once that way. Well, I guess if you might do a long pipeline, you kind of can. But
yeah, this is there are other tools who can do this better. The next one is split-n, xargs-p, and parallel. There's a program for that. And note these programs are invoked in parallel by these. They need to output atomically for each item processed, which the GNU core utils are careful to do for factor and SHA whatever size sum. And generally, commands that use standard I/O for output can be wrapped with the standard buff-O capital L command to avoid intermixing lines from parallel invocations.
Yeah, I've used xargs-capital P quite a few times on FreeBSD, and I helped port a patch that does, I think, -P0 does as many as it can possibly do at once, basically. If you really want to just do them all, if I can support them all.
Yeah, make as much use of the CPU as you can.
Yeah, depending on if they're very short-lived, then you want to use quite a few. Otherwise, you probably want to limit it to about the number of CPUs you have.
Yeah, definitely. The next one is make-j, which many people know from the ports compiling days to make
Well, especially if you're compiling all of FreeBSD on a machine with 32 cores, you definitely want to take advantage of this.
Yeah, like make build world or whatever world you're building. So most implementations of make now support the -J option to process targets in parallel, and make is generally a higher level tool designed to process disparate tasks and avoid reprocessing already generated targets. So for example, it's very efficiently used when testing core utils, where about 700 tests can be processed in 13 seconds, and this is on a 40-core machine, so you can get a lot of things happen, or like a lot of make files are run with -J to make it quicker. The other one is implicit threading. So this goes against the Unix model somewhat and definitely adds internal complexity to those tools. The advantages, however, can be less data copying overhead and simpler usage, though its use needs to be carefully considered. Disadvantage is that one loses the ability to easily distribute commands to separate systems. Examples are GNU sort and turbo line count. That was new for me, this last utility, but there's more examples in the blog post. So the blog post basically covers the use case of counting lines in parallel. So first we create a test file, of course, of 100 million lines using SEQ. And there's another test with long lines, which has 10 million lines created in a similar fashion. So this is in the show notes as well. And they also define their own add function, which is basically just a helper function to add a list of numbers, so you can get at the end an output how quick this process went. And of course, if you run this multiple times, you get cached files, and these are not I/O bound by this way. Therefore, the blog post author limits the number of processes in parallel to number of proc, though you would generally benefit to raising that limit or the number of jobs that are waiting on your network or disk, depending on what kind of thing you're trying to parallelize. So the first one is, of course, line counting with WC-L, and that pretty much counts the lines. And if you run it without any parallelization software, you get a baseline of how this operation, how much time it takes for the lines.txt and the long lines, the 1 million lines and 10 million lines. And this is around a couple of seconds, so counting 10 million lines and 100 million lines takes a while. So this is our baseline for comparison when we're now doing the parallel versions. And there's also a turbo line count, which uses multi-threading, and this cuts down the time somewhat. It's not that bad. So it lists the third fastest and second fastest there, and also has comparison between real and user time. So this is also important to remember if you spend a lot of time in a user context or in the real context of that time. And split -N. So note that using -N alone is not enough to parallelize. So for example, this will run serially with each chunk, because since --filter may write files, the -N pertains to the number of files to split into rather than the number of processes in parallel, or to process in parallel. So you pass that, and there's an example here, and this one cuts down a little less well than the turbo line count, but it's something. I know it's a very small test case. It's just line counting. Other test cases may have different results, but for this one, it's a good comparison.
Yeah, there's lots of different ways to do it, and it can really depend on a number of different factors. The amount of copying that has to go on, and how much time you spend actually doing the splitting and so on versus doing the counting. And That's where things like ttrace can be helpful to figure out why it took longer or whatever. But it also sometimes even just, I think it's trust -C to see how many different system calls it did. And as you can see, for some of them, they're faster for long lines or faster for short lines, but not the other, where there's not really one solution that's always best for each different thing.
Yeah, you can get different
ideas. It looks like the xargs -P was the joint fastest option.
All these. Yeah, and there are examples for each one of those, how they were invoked. And Xarc is generally available on most systems. I haven't seen a system recently that didn't have it. So it's good to have in your toolbox to know that it exists and also how to use it.
Yes, and they also use make-j to run many of them at once, which is interesting.
Yeah. Yeah, so combining these, of course, will, if you don't create too much overhead, will speed it up a lot. So if you're trying to get things faster, then check out that blog post further and get some ideas how to do this.
Our second sponsor this week is DigitalOcean. Head over to digitalocean.com and check out their pricing and options.
Yeah, so they also have some news. So DigitalOcean Spaces, they are now available in Amsterdam as well. And that's so what are spaces? Spaces are pretty much object storage designed for developers. So you can have a little space, just a couple of clicks, and then you can pretty much, so what the pricing is for a space is $5 per month and includes 250 gigabytes of storage and 1 terabyte of outbound data transfer per month for any of the data center with spaces deployed. So this is currently NYC3 and AMS3 as well. So an inbound data transfer for uploading is free. And if you want to get additional bandwidth, because 1 terabyte isn't enough for you, then it's available at 1 cent per gigabyte of data transfer. And an additional storage is 2 cents per gigabyte stored. So this is an option that they have now for developers. So spaces are a good way to simply and scale your object storage that you have.
Yep. And like we said, you can get a droplet for as cheap as $5 a month, and then scale it to whatever size you need. I noticed the $15 a month one now includes 3 gigabytes of RAM instead of less.
Yeah, you can more than previously, which is exciting.
Yes, I think the $15 one is a new increment. Before it was 5, 10, and 20. This allows you to get just one CPU instead of 2 like you get the $20 one, but you get 3 gigs of memory, which makes it a much more useful droplet. So they're adding more options to give you this nice combination of lots of memory, reasonable amount of CPU, some SSD back storage, and lots of internet transfer. 3 terabytes for $15 is a good deal.
Indeed, yeah. And it's super easy to get started. So you just select an image or an app you want to run, like a blog or some kind of database software, then choose a size, like Allan said, one of these sizing options that they offer, and then just select a region where this droplet should be deployed or running, probably close to your location or where your customers are or wherever you want to run this, and then your DigitalOcean droplet will start and you can connect to it and let it do its little thing that it's doing. It's that easy.
Yes, that new $15 one is quite interesting. But if you do decide to give it a try, when you sign up, use the coupon code FreeBSD Now, all one word, and you will get an extra $10 added to your account. So you can try that $15 one for just $5, or get 2 months of the $5 one for free after you pay. So you should definitely go over there, check it out, and pick a location. They have lots of locations with San Francisco, Toronto, New York, London, Amsterdam, Frankfurt, Bangalore, Singapore, and I'm sure I missed one. Frankfurt.
No, you had that. Amsterdam.
1, 2, 3, 4, 5, 6, 7, 8. There's at least 8 different locations anyway.
Yeah, somewhere
pick
near
one
you.
Near you. Have fun.
And it's easy to get started, and they have a nice UI, and they will tell you how your little VM is doing, like in CPU or what kind of bandwidth it's using. So it's all available on their website and built in, so you don't have to buy any extra managing utilities or so. It's all available right away.
Yeah, and with the new $15 droplet size giving you 3 gigs of memory, it's now much more sensible to be able to connect their block storage to it and run ZFS.
Yeah, so check out DigitalOcean and tell us about your experiences with them, what you're doing with that. might be interesting for our readers and listeners.
So, next story.
Yeah, so the next story is about OpenBSD, and OpenBSD gives a hint on forgetting unlock mutex. This is over at Nan Xiao's blog, and so it's it starts with a very simple, actually C++ program, which has just include mutex and then int main, and it creates a mutex m, and that locks that mutex, and then returns 0, and the program exits. So you create a mutex, you lock it, and then the program ends.
And you forgot to unlock it.
Oops. Could happen in a simple program like this. You lose the overview of that whole thing, and yeah, there you have it. So the mutex m forgot to unlock itself before exiting the main function. And if you test that on GNU Linux, and in this case Arch Linux as the testbed, this is a pretty recent Arch Linux, I think. You compile that with Clang++, of course, and you execute that, and, well, the process exits normally, as it should, and no more word was given because there's no output, of course. And now if you build and run this on OpenBSD 6.2, same thing, you run the same Clang, and you run this thing, of course, then there's a message for you saying that pthread _mutex _destroy on mutex with waiters. So OpenBSD prompts that and will tell you that this mutex still wasn't.
There are people
unlocked.
waiting for this lock to be unlocked, and you just destroyed it, and so it will never be unlocked. And so those people will wait forever and probably be deadlocked.
Yep. Bad programming. Bad programmer. So people should fix those. If you see those messages on OpenBSD compiling stuff, then there's something not locked. Or not unlocked, actually.
There's a kind of related system in FreeBSD for the kernel called Witness that does lock order checking. To prevent a deadlock, if you have two locks that you're going to take, you have to make sure you take A and then B. If you try to take A and then B, and a second thread tries to take B then A, then what can happen is you get A, and at the same time the other guy gets B, and then you try to take B, and you can't take it because the other person has B already. And they're trying to take A, but they can't take it because you already have it, and then you're both stuck forever. Whereas if you take A, and then they try to take A, it won't work, and they'll wait. And then you'll take B, do your work, and then unlock B, and then unlock A, and then they'll be able to lock A, lock B, and continue. So when the wrong order is detected, when the witness system is enabled, which is in the debug kernels on FreeBSD, you will see this LOR, or lock order reversal message, and it'll show you where in the code this is happening and let you track it down and try to figure out what the problem is. There are a couple of known false positives or cases where it's okay that happens, but most times when you see that, it's not good.
It should be reported if you haven't seen this before.
There's a high overhead to doing the detection, and that's why it's only on in the debug kernel, not on in the regular kernel you use, because it will impact your performance by quite a bit.
Yeah, that's why most people, or most release versions or actually all release versions of FreeBSD have that disabled. But if you're doing kernel work, then this should be your activated option. So yeah, nice to have this in OpenBSD and helping programmers do the right thing with locking and properly unlocking again. So, time for our BSD bits this week, starting with updates to the NetBSD operating system since OS Huck number 57 and 58. So this is from Sevan, I guess. Yeah, it is. He's pretty much our United Kingdom reporter for anything about NetBSD, I guess. So there's OSSG and OS Huck meeting later this month at the BCS. Did you say where that is?
That's the Computer Society. It's where the last one was.
Right. Okay. So people...
And there's a link if you want to register and attend.
Yeah, there's events.bcs.org/book/2717. And there's speaker announcements. So there's a chip hack experience. So chip hack is an occasional 2-day workshop introducing students and hobbyists to FPGA design. So if you're interested in that, check that out. There's also updates to the NetBSD operating system by Sevan itself.
Well, the interesting bit about that first talk is it's actually about reimagining EDSAC, which is the first big computer in the UK. It was like the very first computer, and basically reimagining it using some chip hacking and an FPGA. So that's quite interesting if you're computer history buff.
Okay, and another one is the interplay between semantic coupling and code change of software classes. So this is also, it's a presentation, and it starts with during maintenance, developers must ensure that related entities are updated to be consistent with the changes, and there's some studies done in static change impact analysis domain. So if you're in that interested, check that out. So will there be recordings for that? Do you know about this?
I don't know.
Then we'll ask Sevan to give us an update next time.
Yes.
When that is over. We'll bug him about that. All right. Our next item is creating a jail with FIFO and DigitalOcean. So this is over at projectfifo.net. So
yes. So this is from the people that did the vmadm thing we covered a little bit earlier. In this tutorial, they'll set up the Project FIFO stuff inside a DigitalOcean, starting with the installer and continuing through creating the first jail with it.
Mm-hmm. They seem busy in that area, which is good for not only the jail.
The bad news is currently the private networking in DigitalOcean does not allow multicast, which means that Project FIFO's node discovery does not work beyond a single node by default. There's a few ways around it, like using tunnels or VPNs, but that's beyond the scope of this little write-up. The good news is that Project FIFO's tools work flawlessly on DigitalOcean FreeBSD images. The installation takes just a few minutes and works very well. The whole process takes a bit less than 30 minutes to do, and most of that time is spent compiling the kernel to enable the RCTL and VNet options, which I think are both on by default in FreeBSD 12.
Oh, okay.
So they spin up a FreeBSD 11 ZFS image on a reasonably sized droplet. They used Frankfurt because that was closest to them and set it up. Then they downloaded the source code and extracted it so that they could modify their kernel and make the new FIFO kernel by adding vimage, the resource accounting, and the resource control stuff. Like I said, all three of those are on by default in FreeBSD 12, so this step won't be needed in the future. Then they built the kernel, set up their loader.conf to load the couple of modules like Linux and Linux 64 and their tempfs. They used port ACLs to run stuff as non-root and so on, and enabled the resource accounting. They created some ZFS datasets, configured their network. They added the Project FIFO repo to package so they could install vmadm and their chunter and login programs.
Oh, this is interesting stuff.
Get that set up. Install the management tools with FIFO Sniffle and Snarl and Howl. Interesting naming scheme.
Seems like
Get that all set up and running. Get those services running, and you can see those going there. And then they set up their storage, and you get the Project FIFO web interface.
Cool.
And you see them go through the motions and set up some IP ranges and some networks, and import a data set of FreeBSD, and create their jail. Splat. And now you can see you're in a FreeBSD jail called My First Jail running FreeBSD 11.1.
Ooh, nice. People should check that out and see what they have.
The best part is if you're only going to use it for half an hour, that DigitalOcean droplet is only going to cost you a couple of cents.
Yeah, because it's quickly to start up, to test it, and if you don't need it anymore, then you just remove it. And
At fractions of a cent per hour or whatever. You can even use one of the beefier ones if you want that compile to go faster, knowing that you're going to turn it off after an hour. It's a great way to be able to experiment with it without running down the battery on your laptop or something, trying to do it on your own machine.
Yep. Very cool. The next item is, I'm thinking about OpenBSD again. This is from Steven Rosenberg. And so he basically received an email from the BSD magazine folks asking for an interview. And he kind of demurred because he's barely using Linux right now, let alone BSD. And his intense BSD period was around 2008 till 9, when he had a laptop that wouldn't boot from CD. And OpenBSD's floppy image, you heard that right, allowed him to get it up and running. So he blogged a lot about it and had a lot of fun with OpenBSD and tried a couple of others with encodings, both catastrophic, or with endings, both catastrophic, not encodings. With endings, both catastrophic, in this case FreeBSD, where updates puzzled him and broke the system, and anticlimactic, DragonflyBSD in this case, where too many applications didn't work. And he did a few sporadic OpenBSD tests since then, but circumstances at both his work and personally kept him away from that, and seeing overall interest in free software wane considerably since Windows 7 came out, and his growing interest in programming also led to that. And so at this point he was running Fedora on his old laptop and Windows 10 on the Windows subsystem for Linux on his new laptop. And so he writes a little bit that he's still involved in programming, Ruby, Java, and the Bash shell, and a little bit of Perl. And in his day job, he can mostly leave his Citrix-centered or Citrix-delivered system behind in favor of a whole lot of WordPress. So his question was, after he kind of got an old Roku image for video, so his laptops didn't double as entertainment machines. So he asked, could I set up my old laptop as a development machine using OpenBSD? And the only difference in favor of this is the JDK being available as a package. And so he installed a Java development kit back in 2009. Was far from easy, and he can't remember if it was even able to do that. And he continues walking around the installation and figuring out what new things were now available in OpenBSD since last time he touched that. So he also lists a couple of things that he used to learn about the OpenBSD project and what they are doing. So he has learned that there are OpenBSD communities on Reddit and on Facebook and probably some other places. And he collected some links in his blog post to help get OpenBSD systems installed. So he has linked those for people who want to follow that. And so his updates, with the newest one first, he has done 2 OpenBSD 6.1 installations on his HP Pavilion G6, and the internal Atheros Wi-Fi doesn't work, so he's using the wired network and an old Realtek-based USB Wi-Fi stick. He blew up the first installation, and now he's working on the second. He still can't believe that it's so easy to get the JDK installed and running, so this is an improvement from his previous try. And to just add the package, and then you set your path in the profile, and that's it. Yeah, so this is a nice user experience.
On FreeBSD, you don't even have to add the path.
The port does
package
that.
Install OpenJDK 8, and boom, good to go.
Mm-hmm. Yeah, it's interesting. Did you remember last time people were, when we were at FOSDEM, people came to our table and tell us, we've been running FreeBSD forever in our data center, and it's working so well. What did change since FreeBSD version 5? And we were like, a lot. So it was running nicely for them. They didn't have a need to update. And now they're asking us, hey, what's new in the system? And it's a lot. So if you had a timeout for a while, then there's some new stuff for you to discover.
Yep.
Yeah, so next item is kernel ASLR on AMD 64. This is over at the NetBSD blog, and it talks about being able...
Yeah, so Maxime points here, he says, Recently, I completed a kernel ASLR implementation for NetBSD's AMD 64 port, making NetBSD the first BSD system to support such a feature. Simply said, KASLR is a feature that randomizes the location of the kernel in memory, making it harder to exploit several classes of vulnerabilities, both locally, like privilege escalation, and remotely, like remote code execution. The current design is based on a specialized kernel called the prekern, which operates between the bootloader and the kernel itself. The kernel is compiled as a raw library with the generic KSLR configuration file, while the prekern is compiled as a static binary. When the machine boots, the bootloader jumps into the prekern. The prekern then allocates the kernel at a random virtual address and jumps into it. And finally, the kernel performs some cleanup and executes normally. Currently, the kernel is randomized as a single data block. That is to say, a random virtual address is chosen, and the kernel's text, read-only data, and data sections are mapped contiguously starting from there. That has several drawbacks, but this is just the first shot. To complete this implementation, work had to be done at 3 levels: the bootloader, the prekernel, and the kernel. I committed several of the kernel and bootloader patches discreetly a few months ago to pave some way for the real changes. In the last few weeks, I managed to change the low-level x86 layer of the kernel and replace several hard-coded and sometimes magic values with variables in such a way that the kernel can run with a non-static memory layout. Finally, the last step was committing the prekernel itself to the source tree. In a follow-up, he's actually done the bits of breaking the kernel into discrete parts and randomizing where they go. Other future work includes modifying several kernel entry points not to leak the kernel address to userland, randomize the kernel heap as well, because it's still static, and fix a few other things that might need some more work. But then it's got a quick how-to on how to try it out and see how it works. And the feature will be available starting with NetBSD 9. Once it is stabilized, it may be backported to NetBSD 8. But until then, please start testing.
Yeah, great. More ASLR in different BSDs on different levels, of course. Next up is a call for participation for the BSD Dev Room at FOSDEM next year. So FOSDEM next year will be in Brussels, in Belgium, of course, as always. And it's on the 3rd and 4th of February, 2018. So mark that in your calendar. FOSDEM is a huge conference, and they have individual dev rooms for projects or specific topics you want to talk about. So they had a BSD Dev Room for a number of years now, and they are looking for people to submit talks for that. So if you want to just listen a whole day, this is the Sunday, of course, to just BSD content, then you should submit or go to the FOSDEM Dev Room, or submit something if you want to give a talk there. Allan will be there, I will be there, a lot of other BSD names that you might know will be there. So it's a good way of meeting us and other people. And
yes, so the submission deadline to get your talk into the BSD Dev Room is Sunday, November 26th. One of the nice things about the Dev Room is your talk does not have to be 45 minutes long. You can give a 10 or 15 or 20-minute talk. Just indicate that when you fill out the little form to submit a talk proposal. And we have the whole day, and we are hoping to wiggle it around.
Yeah, so this is the BSD Dev Room is organized by Rodrigo Osorio and Benny Seeger, and they both make sure that we have a good lineup of talks and discussions. Yes.
And the chat room points out, I think Benedict misspoke, the Dev Room is on Saturday, February 3rd.
Oh, is it on Saturday? Okay, then I've mixed it up.
It says that in big letters right on the page there.
Yeah, there it is. Ah, right, I see it. Yeah, we haven't got the feedback yet, but there should be a FreeBSD table there, or FreeBSD Foundation table, and Allan and I will be there, and if you see us there, then say hi, and we'll make a selfie or whatever. Last year, random people stopped Allan, he didn't know about, and tell them they were watching BSD Now. So yeah, that's a good way of meeting us.
But yes, we look forward to seeing more people there, and we'd really like to see more talks at FOSDEM. In particular, the dev room's a little smaller than you would think if doing a BSD can or something. There's there's like 4,000 people attending, but the BSD dev room only holds 100 and something, so there won't be too many people in the room. It's a great event because it's not just operating systems. Like every single open source project has people there. So like there's a whole dev room dedicated to like VLC if you want to find out what's going on in video players, or there's an entire room for like basically every open source project. Yeah. So it's also a great way for FreeBSD to fly the flag and make sure that all those tools like VLC remember that FreeBSD is a thing and people use it and we would like it to keep working. So, don't decide to just be Linux only. So we'd very much like to see as many people as possible come out to FOSDEM, but also we'd like to get a nice diverse set of talks for the dev room. And so you have about a week left to submit, so hurry up and get on that.
Yeah. Okay, and our last item is a reminder for an item we had before. So this is about the BSD Stockholm meetup. So this is going to be happening soon. This is Thursday, the 23rd of November at 5:30 p.m. And Niklas Seising is organizing that. And there's a link in our show notes for the meetup page that they have. And if you're in the Stockholm area, and some people have already signed up for that one, that it will be there, you can join some discussions with your Swedish BSD folks.
Yes, should be good. I recognize a couple of people's names on the list of attendees.
Yep. And we'll probably ask Niklas to tell us how it went afterwards, and hopefully this will be a recurring event in the future, so that this is not just a single one-time event. Introduce the sponsor for that section, which is tarsnap.com. Have you done a backup recently? Well, you should. And while you're doing that, you should do this securely and also in a way that you are the only person to access that backup. So if you're doing online backups, then you should be the only person being able to decrypt that backup. So the way Tarsnap does that is you take your files that you want to back up, it encrypts them locally on your machine before they go out into the wild internet, and then the encrypted copy is being stored in the Amazon cloud, which Tarsnap uses for the backups, and you're the only person holding the backup key or the decryption key, and next time you need that backup, you lost some files or deleted them by accident, you can get them back from the Tarsnap cloud, and since you have the key still, if you delete the key, no one can retrieve them anymore. But if you still have the key, then you can get your files back. And no one else on the evil internet can access that file without having the key. And this is what Tarsnap provides for you. The whole management of like the key creation and uploading of the data and all of these bits and pieces put together in a nice interface. Because if you know tar, then you also know how to use Tarsnap, basically.
And it works across basically every operating system, so you have no excuse for not doing the backup.
Yeah, so next time you want to get your files backed up, try out Tarsnap for a very low fee and get started.
It's $5 to give it a try. I highly recommend it. Once you start doing the backups, you'll be like, wow, I really like this.
I might as well back up much more files. Yeah, so check out tarsnap.com and start taking backups.
Okay.
All right.
Feedback.
We have feedback. We're still a little bit back from our list of submissions of feedback. This one is about vBSDCon. So it's Architect from the chat that we have regularly running in parallel to the show. He writes, "I'm one of the viewers that decided to haul himself way across the country to attend vBSDCon in anticipation of meeting yourselves, Dan from TS and Sean Webb, as well as hopefully pick up some useful data that I can apply with my new position as NetOps, but not really networking position." That's an interesting title. Building out infrastructure for internal company use. While there wasn't a ton of data that was terribly relevant to what I was looking at in particular, it was a great experience, even though Sean had to leave before I could meet him. He writes, I'm very introverted and fairly shy individual, so I didn't end up talking to as many people as I probably should have, but it was a great talking to the various people at the different booths and at the table in the main conference hall. Well, we talked, we had...
That was definitely my problem at my first conference. I met like 2 or 3 people out of the 300 that were at the conference. It gets easier.
It can be intimidating, yeah. And the sheer knowledge that some people emanate is like, whoa, I shouldn't talk to that person because he would. But people are nice. Mm-hmm. It's just the first time you don't know these people, and everyone is nice.
Most of them are just as shy as you, and so you're both looking at each other like, I wish they would introduce themselves to me.
Yeah, you broke the ice with your first conference, and the next one is going to be easier because by then some people know you already. So it was a great experience, he writes, overall. The only flaw was that I have a hard time branching out, and I unfortunately slept through the BSD certification exams. But those are completely on me. Hopefully next conference I'll get out there a bit more and maybe got certified. Excellent. The BSD community is fantastic, even though I'm a bit of an outlier with DragonflyBSD being my daily driver.
Well, I can introduce you to some people at BSDCan that are big into Dragonfly if you'd like. Maybe help get you started there.
Yeah, or submit a talk. Could be something people haven't heard about too much, so we might as well gain some interest from those people.
Yes, and at BSDCan there's also a first-timers group. So on the Thursday before the conference starts, there's a meetup where we provide you with a bunch of information, make it easier to, little things that it's like, I wish I had known my first time kind of things. And we'll also give you a list of people who you will know and will know you, and we'll be perfectly happy for you to come up and ask them, hey, could you introduce me to so-and-so or something to get a start? Or, who should I talk to if I want to talk about Dragonfly, or if I want to talk about, UFS or ZFS or whatever you want to talk about. I'm having this problem with jails. Who should I talk to? The first-timers group tries to make it easy for you to know a couple of people who you can ask for that kind of direction.
Yeah.
Because, once you have that, you'll find that even if you're shy, if you're talking about something you actually know a bit about, like the way you use jails, suddenly it gets much easier to talk to somebody. And then you realize that even if you don't know exactly what you're doing, talking to people is very helpful.
Yeah, definitely. Or you team up with someone who's also there for the first time, so you both have someone to talk to, and from there you work yourself through the room, and by the end of the conference you know everyone.
Exactly. So if you recently had your first time to a conference, or even if it wasn't recently, if you want to write us in about your first time, I think sharing more of those experiences will help everybody and maybe encourage that many more people to try for their first time.
Yeah, sure.
I think my biggest regret of this whole thing was that I knew that BSDCan was a thing in 2006, but I didn't go my first time until 2012. Such a waste of time.
That's a lot.
All those years I could have been going to BSDCan and didn't even know it.
Yeah, right in the backyard compared to other people. But yeah, there's future conferences, and the next one is going to be as awesome as the previous one. Yeah, so thanks for writing that, and see you at the next conference. The next one is from Brad about packages and package dependencies. This is also, someone from VBSD. Yeah, Brad Alexander, I remember him. He writes, hi, Allan, Benedict, and JT. It was great meeting up with you guys at VBSDCon last weekend, so way back when. I have a question regarding packages and package dependencies. So he's running TrueOS unstable, and he ran into an issue after an upgrade on TrueOS on his laptop, which is a Lenovo T530. After rebooting into the new boot environment, I noticed that Firefox wouldn't start. Chris Moore said that uninstalling GCC-ECJ would solve the problem. However, its removal also uninstalls a number of packages. So he lists those packages here, including some more... mostly GCC and some dependencies of that, including some KDE ones, or KDE itself, actually. So his first question is, why would GCC 5 have GCC ECJ, which is the Eclipse Java compiler, as a dependency?
I'm guessing it's actually the other way around. You're trying to uninstall GCC ECJ. Actually, I guess it is. That's interesting. I'm guessing it might just be one of the compile options of GCC 5 is to include ECJ and ends up getting listed as a dependency. That might be... I wonder if that only happens on TrueOS, because on TrueOS they default to a policy of including most of the options in every package to avoid you running into the situation whereas, the package doesn't include that option, you have to build it yourself. And maybe the Eclipse Java compiler was a bad option to include in GCC in that case.
Yeah.
The BLAS, OpenBLAS, and LAPAC, I wouldn't have known what those were until BSD Taiwan last week, where I learned about what them are. Those you should be fine without. I'm not entirely sure why KDE depends on some of that. I'm guessing because KDE depends on the KDE education, and the education stuff depends on the BLAS stuff for science computing, and on and on and on.
Yeah, so it's a whole dependency chain.
Yeah, so but you might be able to cheat. You might be able to cheat and do package delete -f GCC-ECJ to force it to delete only that package. Although it'll probably cause other problems, but it might get Firefox to work. But yes, Q5sys, our producer, who's also a TrueOS developer, notes that they're going to remove the ECJ thing, so it shouldn't be an issue going forward.
We get something from the chat room here. Niklas says there used to be an option to compile GCC with Java, like you mentioned, Allan, which makes it dependent on the ECJ. Some kind of bootstrapping going on there, but it's
like I guessed, it's an option, and because the way ports work, there's just not a way to express the weirdness of the dependency there. And ends up depending on it, even when it doesn't necessarily need to.
If Chris Moore says that uninstalling that will solve the problem, then he figured this out probably, or someone else has done this before. His second question is, why would a compiler package depend on a compiler? This is
yes, I'm guessing it's just that GCC 5 was compiled with the Java option, and the Java part of GCC requires the GCC Java compiler, and that's how it goes. Hopefully that'll be fixed upstream soon, and when you just do a package upgrade, it will elide ECJ for you. But like I said, package delete -f for force should allow you to delete just the one package without all the dependencies, so that you don't uninstall KDE. Unless you're not using KDE, then go ahead and nuke it.
Yeah, you have a boot environment, you can still do a snapshot.
Yeah, make a boot environment before you do it and try it and see what happens. If it doesn't work, just reboot onto the working boot environment and try something different.
Okay, yeah. It was nice meeting you at VBSDCon. See you next year, or the year after, actually, or at another BSD conference next.
Yes, BSD Can, Meet BSD, lots of conferences.
Good opportunity.
I didn't even list the ones that aren't in North America.
Yeah, there's too many to list. Okay, that's for this question. The next one is from Lars about DPB. He writes, hi, back a very long time ago, in a galaxy not so far away, 2014 actually, BSD Now published a tutorial on building OpenBSD binary packages in bulk using distributed ports build, or DPB. It would be really very interesting to hear from the maintainer, Mark SB, in an interview. Or it could be someone designed or designated by him as knowledgeable to talk about it in its place. So DPB is really quite interesting, and it would be very cool to hear about its details, especially from a developer perspective. Maybe some future conference or future BSD Now episode could even have a panel discussion between experienced Poudriere and DPB users or developers. And does Dragonfly and NetBSD have a similar package?
We interviewed Mark SP about package builders in episode 94, which would have been in the middle of 2015. So, already done. Check out episode 94.
Okay, yeah, there might be even updates after that. So that's 2 years already.
Yes, now that it's been 2 and a bit years since then, there's probably even more updates. We might have to get Mark to come out and talk to us again.
Yep. And seeing what's new and how these compare to other tools or other BSD packages.
For Dragonfly, I'm not sure exactly what they do. I think Dragonfly has jail, so they might just use Poudre. I'm not sure. They use the FreeBSD port system now, so I imagine the tooling is the same. I don't actually know for sure. NetBSD, their packages are actually built on SmartOS zones now. Package source, because package source binaries because package source works on Solaris and NetBSD and Linux and Mac, they actually use SmartOS donates the compilers and runs the builds for NetBSD that way. I heard a little bit about it at BSD Taiwan. And apparently Dragonfly uses Poudre and or Synth. We also had an interview about Synth with the author. I don't know when that would have been, though.
Yeah, but
it's
in the archive, so...
Yeah. Yes,
all right.
Having done 220 episodes, we've interviewed 140, 150 people, I think, which is quite a bit of stuff.
Yeah, and re-interviewed them if they had updated work that they'd done in the meantime. So, yeah.
Yes.
More stuff.
Our last one is a little comment that I got, kind of out of band of the show, but our friend Alex Rosenberg, who, if you remember from our interview, was it 1 or 2 years ago? It was December-ish, or end of December, 1 or 2 years ago. He was the manager for the PlayStation 4 platform architecture team. So basically helped them design the Orbis OS on top of FreeBSD. He's since moved on and gone to Apple, or back to Apple because he worked there before he went to Sony in the first place. Anyway, he recently heard our story about the PS4 downloading and thought he would explain what the motivation actually was. So he says, the motivation of reducing the download speed during gameplay isn't about saving CPU overhead. To the contrary, the OS threads are pinned to a single CPU core to make sure they stay out of the way of the game. The motivation of shrinking the socket buffer really small is to reduce the memory used by the operating system for the background downloads so that memory can all be given to the game to use. Lots of effort is expended to give as much of the hardware directly to the game and to get out of the way. There's there's things like paging just get in the way, so they purposely, when a game is running, minimize the OS down as small as possible, get rid of all the buffers they can, and give all the memory to the game, because the game can use every bit of it to be faster.
That makes sense, and it's impacting the download speed in turn.
Yes, so it's impacting the download speed, but it's, I wonder, it's that's a very crude way of trying to shape the traffic to avoid, causing delay in multiplayer games, but it's actually about saving every bit of memory you can and giving it to the game and making the OS have a minimal footprint. And that is why they do it that way on the PlayStation 4. Not as a way to control network traffic, because like I said, it's not a very efficient way to do that. They do it just to save memory.
Yeah,
thank you very much to Alex for the explanation, because it makes a lot more sense.
Yeah, how things are behaving on the PlayStation 4. All right, that's pretty much the end of this show. Thanks for watching, and if you have something for us, questions, comments, show ideas, topics, or stories you want to mention that you found on the net or wrote yourself, send them to feedback@bsdnow.tv, and we'll cover it in a future episode.
Yes, thank you, and more first-time conference emails, if you please.
Yeah. And stay tuned for Allan's report about the other conferences he visited during the last weeks in future episodes.
Lots more to cover. So, but it's been over 2 hours already, so you guys have had enough for this week.